lab number 22 and talk about solving a system of equations with several different methods. The first method we're going to talk about is the substitution method. The substitution method involves taking the system of equations and isolating one variable for one of the equations. So for this system, we have 3x plus 4y equals 2, and the second equation is x minus 3y equals 4. And we need to find one of the variables and get it isolated. The easiest thing to do is look for one of the variables that has a 1 as the coefficient in front of it. So here the x can be easily isolated by just adding 3y to both sides. So we get x equals 3y plus 4. Then we can take that portion that x is equal to and substitute that for x in the other equation, so that we have 3 parentheses 3y plus 4 plus 4y equals 2. And we can solve that equation for y. So we only have one variable in the problem now. So we distribute the 3, 9y plus 12 plus 4y still equal to 2. And then we would then combine the like terms. 9y plus 4y would be 13y plus 12 is equal to 2. And then get y by itself, or isolate the variable part. So we're going to subtract 12 from both sides. And when we subtract 12, we get 13y equals negative 10. And then divide by 13 is the last step. We get a fraction, y equals negative 13, or negative 10 over 13, excuse me. There's our y value. We can then take that answer and plug it in for y in the equation that says x equals something. Negative 30 over 13 plus 4. Use the calculator here. Negative 30 over 13 plus 4. Math, enter, to get a fraction result of 22 over 3. Or over 13, excuse me. So we have an ordered pair solution, 22 over 13, negative 10 over 13. There's our final answer. Remember that systems of equations can have three possibilities: either one solution, like this example has, or no solution, and that the two equations do not cross in the plane, and infinitely many solutions where the two equations are actually the same equations. All right, let's look at the next method. We'll take the same system and we're going to solve it using the elimination method. So we have 3x plus 4y is equal to 2, x minus 3y is equal to 4, and we're going to use the elimination method. In using the elimination method, the idea is to take one of the variables and eliminate it by making the other equation have the opposite coefficient to that. So when we look at this system of equations, we have a 1 in front of the x and a 3 in front of the x in the first equation. We could turn this equation into a negative 3 in front of the x by distributing a negative 3 to the entire equation, so that we have negative 3x plus 9y is equal to negative 12. And then the first equation, we're not going to do anything to that one, because that would give us opposites on the x. Once I've done that, I can add the two equations together. Positive 3x plus negative 3x, they cancel each other out. 9y and 4y together is 13y. 2 plus negative 12 is negative 10. And there we divide by the 13 again. And there's y being negative 10 over 13. It shouldn't be a surprise. That was the same answer we got on example 1. It's the same problem, just done with a different method. Now we need to use that to solve for x. So I'm going to plug that into either of the original equations. It doesn't matter which one. I'm going to go with the second one because I can just plug in and it's much easier to get it. I don't have to do an extra division step to get x by itself. So it's equal to 4. And then distribute, so x plus 30 over 13 equals 4. We would subtract 30 over 13. So 4 minus 30 over 13. Math, enter, enter to get a fraction. 22 over 13 again. And that's our ordered pair solution, 22 over 13, negative 10 over 13. Same solution that we got with the first example. It's the same system. Let's look at another method for solving a system of equations, and that's going to be using our TI-84 calculator using the intersect feature in the graph of that. So in order to graph these equations, you need to get the y by itself so that we can put it into our graphing feature of our calculator. So we're going to solve each equation for y. So subtract 3x, 4y is equal to negative 3x plus 2, divide by 4. Y is equal to negative 3/4 x plus 1/2. So reducing that fraction. So there's one of our equations. Let's get the other equation equal to y. So subtract x and divide by negative 3. Y is equal to positive 1/3 x minus 4 over 3. So we have our two equations that we're going to graph. Okay, so TI calculator, I'm going to go to the y equals menu and graph those two equations. Y equals negative 3 over 4x plus 1/2. Then go to y2, and I've got 1/3 x minus 4 over 3. Make the graph. We see those two lines crossing right there. Now we could estimate that that would be somewhere between 1 on the x-axis, so it's between 1 and 2, and close to negative 1 on the y-axis where those two lines are crossing. But the calculator has a nice feature. If you hit second and trace, we can find the intersect of that. So that's the fifth option. And then it just asks you, the first curve is this one, the second curve is that one. And it asks you to guess. So you want to move your cursor close to where they are crossing and hit enter. And it gives us the decimal approximation for that. And take those and negative 1 or 1.69, round the two decimal places there, and then negative 0.76. Oh, 77. The approximation for that. Using the intersect feature, the approximation should be fine. Okay. One more method I want to talk to you about is using the matrix method, using the calculator to use the reduced row echelon form for solving that. And so you want to make sure your system of equations is in standard form with x and y on the same side for both equations. And so then your matrix that you're going to enter will be a 3, 4, 2, 1, negative 3, 4. That size is 2 rows by 3 columns. Okay? So I'm going to enter that matrix into our calculator. So to do that, you're going to hit second and then the X inverse button. So get to the matrix menu. We're going to go over to edit, select matrix A, say 2 by 3. Put the size of it. Then you're going to enter in this matrix. 3, 4, 2 is the top row. 3, 4, 2. The bottom row is 1, negative 3, 4. 1, negative 3, 4. And second, quit to get back to the regular calculator screen. Now we need to tell our calculator to solve that matrix using reduced row echelon form. So we hit second X inverse to go back to the matrix menu, and then go over to math, and then we're going to look for RREF. And the shortest way to get there is to press the up arrow key, and it's down toward the bottom. RREF. 2 R's, an E, and an F. Hit enter. And then you need to tell your calculator which matrix to use. So we're going to hit second matrix, and we put it in matrix A. So we tell it to use that matrix, enter. And the good thing about using the matrix is we can convert that to a fraction by hitting math, enter, enter. And we get this matrix as a result: 1, 0, 22 over 13, 0, 1, negative 10 over 13. That tells us that x is equal to 22 over 13, and y is equal to negative 10 over 13. Get that same ordered pair for this system of equations. No matter which method that we use to solve this, we get the same ordered pair for that. So there's 4 different methods for solving the same linear system of equations. Math 110, lab number 22.